Hi, my name is Gordon Hunter, and today I'm going to be doing a teaching demonstration on limiting reactant. These are some slides that I've used previously in general chemistry classes, so we'll just jump right into it. Whenever you make something, you're going to be limited by how many ingredients you have. So if you want to make a certain product, the ingredients that you have will tell you how much of that product you can make. Using a sandwich as an example, let's say your favorite sandwich is a tomato and avocado sandwich. And the best recipe you know for a tomato and avocado sandwich is 2 pieces of bread, 3 slices of tomato, 1 avocado. That makes you 1 sandwich. So now you're going through your kitchen and you're trying to get all these ingredients together, and you find that you have 8 pieces of bread, 5 avocados, and 15 slices of tomato. So how many sandwiches can you make from that? A couple of other questions. What ingredient limits how many sandwiches you can make? And is the ingredient that you have the least number of also the same as the limiting ingredient? So I've broken this down into all of the ingredients that you have. You have 8 slices of bread, 15 slices of tomato, and 5 avocados. So if you kind of go through and just pair these up to make sandwiches, 2 slices of bread, 3 slices of tomato, 1 avocado, and you cross off after you use the ingredient, run out of bread. So this tells you that you have to stop making sandwiches now because you no longer have one of the ingredients that are necessary. In this case, it's the bread. So which ingredient is limiting? The bread is limiting because that ran out first. You have excess of the other ingredients. The tomato, the avocado. You could make more sandwiches with those, but you don't have any more bread. So was the ingredient that you had the least of to start also the limiting ingredient? Well, you had 5 avocados. That was the least number of something of the ingredients. But bread was the limiting ingredient. So you don't always know just by looking at the number of ingredients that you have which one will run out first. Another example, using pancakes. Let's say your favorite pancake recipe, 2 cups of pancake mix plus 1 cup of water will make 15 pancakes. And that's the ratio that you have to use to make the best pancakes. Someone gives you this for ingredients, 16 ounces of pancake mix and 12 ounces of water. How many pancakes can you make with that? Well, you have to use this recipe, but you're given the ingredients in ounces. These units don't match the units that are in the recipe. So you need some more information to be able to solve this kind of problem. And the information that you need is some kind of conversion or equivalence statement between cups and ounces. For pancake mix, the equivalent statement is 4.62 ounces of mix is 1 cup of mix. And then for water, 1 cup is 8 ounces. So now using this information, you can solve how many pancakes you can make. So you start with just one of the ingredients, in this case 16 ounces of pancake mix, that's what you're given. The equivalent statement, 4.62 ounces of mix is 1 cup. You put the ounces below the line because you want the units to cancel. 1 cup and 2 cups of mix makes 15 pancakes. There's another equivalent statement. This is from the recipe. 2 cups of pancake mix makes 15 pancakes. Cups cancels, ounces cancels. You're left with the unit that you're trying to get to, pancakes. 16 ounces of mix then can make you a maximum of 26 pancakes. So now you do the same thing for water. You have 12 ounces of water. 8 ounces of water is 1 cup of water. 1 cup of water will make you 15 pancakes. That's from the recipe. Going left to right, you multiply everything that's above the horizontal line, divide everything below. 12 times 1 divided by 8 times 15 divided by 1, you get 22 and a half pancakes. So using each of the ingredients that you're given, this is solving for how much maximum product you can make. And it turns out that the water is the limiting ingredient in this case. Water ran out first, you have excess pancake mix. Now you can apply these same concepts to chemical reactions. The limiting reactant in a chemical reaction is the reactant that runs out first. When that reactant is used up, you can't make any more product, the reaction stops. Whatever's left over, the other reactant or reactants, that's called the excess reactant. And then a couple more terms, theoretical yield, that's the amount that you should be able to make mathematically. It's a purely mathematical yield given the limiting reactant that you have. What really happens though when you really do reactions in a real world situation in a laboratory, you never get the theoretical yield. You get what's called the actual yield. So when you really do the reaction, you get the actual yield. The theoretical yield is a mathematical yield. So here's a chemical reaction. Consider this reaction. It's combustion of methane. Here's 1 mole of methane plus 2 moles of oxygen yield 1 mole of carbon dioxide and 2 moles of water. Let's say you wanted to react 5 moles of methane with 8 moles of oxygen. Which reactant would be limiting? Well, in order to solve this, you need the balanced chemical equation. According to the balanced chemical equation, 1 mole of methane will generate 1 mole of carbon dioxide. So if you start with 5 moles of methane, 5 times 1 divided by 1, you're going to get 5 moles of carbon dioxide. If you start with 8 moles of oxygen, according to the balanced equation, 2 moles of oxygen get you 1 mole of carbon dioxide. You put oxygen on the bottom so that those units cancel. You're only going to get 4 moles of carbon dioxide starting with 8 moles of oxygen. Whereas you got 5 moles of carbon dioxide starting with 5 moles of methane. So the least amount of product came from the oxygen. The oxygen was the limiting reactant. And again, you see you had 8 moles of oxygen and only 5 moles of methane, but it turns out that oxygen was limiting even though the number seemed higher. So you can't just look at that number in front of it and say that's the limiting reactant. Here's a conceptual question. Chemical reaction, nitrogen and hydrogen react to form ammonia. You have 3 flasks here. If a flask contains 8 moles of hydrogen gas and 2 moles of nitrogen gas, which of these diagrams would best describe the flask after the reaction is finished? What is the limiting reactant and what is in excess? Well, you look at these 3 flasks, and this first one, A, you have some unreacted nitrogen, some unreacted hydrogen. This tells you that the reaction hasn't finished. So you can cross that off your list. There's 2 other flasks here to consider, B and C. It says you have 8 moles of hydrogen. Hydrogen is H2, which tells you that 8 moles of hydrogen gas gives you 16 moles of hydrogen atoms. 2 moles of nitrogen gas, nitrogen's N2, so that's 4 moles of nitrogen atoms. So we're looking for a flask here that has a 16 to 4 ratio of hydrogen atoms to nitrogen atoms. And it turns out that that's flask C. If you count up the white spheres, which is hydrogen, 3, 6, 9, 12, 14, 16, and you have 1, 2, 3, 4 blue spheres, that's the nitrogen. That tells you that there are some unreacted hydrogen molecules there. Hydrogen is present in excess. It didn't have enough nitrogen to react. Nitrogen is then the limiting reactant. In flask B, this would only be the case, you see there's only ammonia molecules there. This would only be the case if you had the exact right proportion of each of the reactants so that when all the reaction happened, when it was complete, there would be no excess reactant remaining. So to calculate limiting reactants and yields, in problems you'll be given both the reactants in grams, since that's what you'll be given in a laboratory. To determine which is limiting and which is in excess, you have to convert to grams, convert your grams of each reactant to moles first. That was like the problem with the pancakes. We were given something in ounces, but we had to convert that to cups first before we could figure out which was the limiting reactant. Whichever forms the least amount of product, that's your limiting reactant. And then to determine your theoretical yield, you finish converting whichever one of those produced the smaller amount of product. You convert that to grams of product, and there's your theoretical yield. Another term here, percent yield. You take your actual yield, which is what you really got when you did the reaction, divided by your theoretical yield, times 100% to turn it into percent form, and there's your percent yield. So let's do an example of calculating limiting reactant. Here's a practice problem. Following reaction is used to obtain iron from iron ore. You have iron 3 oxide plus carbon monoxide makes solid iron and carbon dioxide, and this is a balanced chemical equation. It says a reaction was carried out with a given amount of iron 3 oxide, a given amount of carbon monoxide, and you have an actual yield in the question. 72.3 grams of solid iron was actually formed. Find the limiting reactant, theoretical yield, and percent yield. So we have to find which one of these reactants runs out first, which one limits the production of iron. Start with, you just pick either of those reactants to begin with. The question said you had 167 grams of iron 3 oxide. This information is from the periodic table. Iron 3 oxide is 159.69 grams per mole. There's its molar mass. Grams goes on the bottom, so that unit cancels. And then from the balanced chemical equation, we have 1 mole of iron 3 oxide yields 2 moles of iron. So you go through 167 times 1 divided by this, times this divided by this, and you get 2.092 moles of iron formed, starting with the amount of iron 3 oxide that you were given. Now you have to do the same process with the other reactant. And if the other reactant makes more than this iron, then iron 3 oxide is the limiting reactant. If carbon monoxide, you do this process and it makes less than this number, then carbon monoxide is the limiting reactant. So here you go. You're given 85.8 grams of carbon monoxide, 28 grams per mole. This is from the balanced chemical equation. Set it up so that the units cancel, and you're left with moles of iron. This number, 2.043, is less than what you got for iron 3 oxide. That means that the carbon monoxide is your limiting reactant. The next step, to get the theoretical yield, you finish this process converting 2.043 moles of iron to grams of iron. This is from the periodic table. This times this, divide this, and you get 114.1 grams of iron. That's your theoretical yield. You were given an actual yield, just found the theoretical yield. So in order to calculate a percent yield, you take the actual yield divided by the theoretical yield times 100%. Actual yield, 72.3, divide by the theoretical yield times 100%, and you get 63.4% yield. So that was the limiting reactants presentation. I use it in my general chemistry classes. Sometimes I kind of pause during those question slides to give groups a chance to work them on their own before going through the answers right away. but there's no students in the audience right now, so I just kind of went through them. Thank you for listening.